always tomorrow. Okay, in trig, the first thing you always hear about when people hear that you're in Greek algebra is, oh, what if you get the unit circle? Oh, the unit circle. The idea of a unit circle is just talking about a circle with a radius of 1. And so it says, let t, being the angle, correspond to some real number. So that's what this means. T is an element of the real number system, and technically, like, real number symbol is like that. It's like a double R, but I don't know how to type that. So that just means if t is a real number, it would correspond to some point on the circle with a radius of 1. Why do we pick a radius of 1? Because it means you don't have to simplify anymore. There's no reducing fractions, because when your radius is 1, all the fractions are reduced already. And so that's the reason we pick a radius of 1, not any other reason. But let's think about what the ordered pairs would be. If this is a circle with radius of 1, at t equals 0, or at 0 radians, what would that ordered pair be? 1, 0, because that would be a length of 1, but I haven't moved up any on the y-axis, so that would be a point 1, 0. And we could pick any point in here, right? We could say some point x, y would correspond to this angle. We could say t, I guess, here. Maybe I should erase my R equals 1. I like theta, but they say t. And we could do that for anywhere, some point. But let's talk about the points that are on, like, where the x and the y-axis hit this circle. So this would be the point 1, 0. What about at pi halves? What would that point be? 0, 1. And over here at pi radians, what would that point be? Negative 1, 0. And I didn't put 3 pi halves on here just because I ran out of space, but we can label it on our circle here. What would that point be? 0, negative 1. Which means yesterday when we were doing that tangent is undefined, and I made you write the point like 0, negative y, you don't have to do that anymore. Now you can actually use the point 0, 1, 0, negative 1, or any of those points in between. So this is my last time I'm going to give you ratios for sine, cosine, tangent, secant, cosecant, and cotangent. We've learned them through SOHCAHTOA, talking about looking at a right triangle. We've learned them talking about just any point xy on any circle with any radius. But now we're going to talk about if you were on the unit circle, you can write all of these the same way, right? But now if the r is 1, we can change r to 1. So we know that sine is y over r, but if r is 1, do you agree that that means sine is just y? Y over r when r is 1? And cosine, the ratio for cosine is x over r, but if r is 1, this is why the unit circle is such a big deal, because now if you know the ordered pair, if you know x and y, you automatically know sine and cosine, because the sine is the y coordinate, the cosine is the x coordinate. And the tangent is still the same, which is y over x. We really should say where x can equal 0. I totally didn't clip anyone. And we can flip this over now. Cosecant is normally r over y, but again, r is 1. So we can say 1 over y, where y can equal 0. Secant is now 1 over x, where x can equal 0. And cotangent would be x over y, where y can't equal 0. So yesterday, those few problems I gave you where it said do without a calculator, I expected you to draw the picture, find the reference angle, draw in the sides of the reference angle, and then do your ratios. All of those special angles, we can put the points on the unit circle that correspond to them, which means we can now evaluate them using the unit circle and these rules here, as opposed to drawing the triangles every time. So we're going to spend the majority of the day talking about labeling the unit circle and where it comes from. And we'll talk about it even more tomorrow, because eventually, if you're going to choose to be a unit circle person, you've got to be able to reproduce this unit circle. Okay, so on the next slide, this should look familiar to what I made you draw out the other day by hand. Remember when I made you draw this out? Better than my hand-drawn ones, right? Squish them together, make the unit circle. That's exciting, right? So first of all, let's remind ourselves of the angles here. I'm going to label the angles on the inside because we're going to label points out here. But remember, this is broken up into what increments? There's 2 pi in 8 equal parts, which is pi fourths, right? 2 pi divided by 8 is pi fourths. So this is pi fourths, or 45 degrees. This is pi halves. This is 3 pi fourths, right? 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 pi fourths. This is 3 pi halves. And this is 7 pi fourths. And you get back to 2 pi, right? And you could do degrees too. What makes these pi fourths angles so special? Well, first of all, let's do these. We can put these points in here, right? On the unit circle, this will be the point 1, 0. We just labeled that. This will be the point 0, 1. This will be the point, oh, why did I put pi out there? Negative 1, 0. And 0, negative 1. Those never change, right? It's going to be the same thing over here. But all the force have a reference angle of 45 degrees, which means if you drew in the reference triangle at pi fourths, at 3 pi fourths, at 5 pi fourths, or 7 pi fourths, that would be a 45, 45, 90 triangle, and you could set it up and solve it hopefully the way you did on your homework yesterday. For the unit circle, now that we know that the x-coordinate is cosine and the y-coordinate is sine, you don't have to think about a triangle anymore. You just have to think about if the radius was 1 here, what the ordered pair would be. And the ordered pair would be what the cosine and the sine of 45 degrees is, which is square root of 2 over 2, square root of 2 over 2. Here's what's really great about the unit circle. Do you agree, since these reference angles at all of these other force points are the same, that the ordered pair is going to be the same two numbers, square root of 2 over 2, square root of 2 over 2? The only thing that's going to change is the sign, positive or negative, for the quadrant. So think over here in quadrant 2. In quadrant 2, it's the same distance away, which means it's the same two numbers, but in quadrant 2, the x is negative. So it's negative square root of 2 over 2, square root of 2 over 2. And what's going to happen down here in quadrant 3? Is it the same distance away also? Yes. It's still pi fourths away, but now we're down here in quadrant 3, which means they're both negative. So it's negative square root of 2 over 2, negative square root of 2 over 2. And in quadrant 4, I have to leave some space over here to draw these points over here too. Y is negative, so it would be square root of 2 over 2, negative square root of 2 over 2. So this is why I separate it into 2 circles, so you can kind of see where they come from first, and then with the next slide, we're going to squish it all together. What was the increments of this one? 30 degrees, or pi 6, right? And so this is how I label my angles. I always do the 6 first, right? Actually, let's do the angles first. 0, pi halves, pi, 3 pi halves. You can really count by 6 all the way around, and for a good while in my life, I would count by 6. Like if I need to know what this was, I would count 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, right? Another way that I do it is I know all the sixths are the ones that are the same distance away, or the same reference angle, right? So this is 30 degrees away. This is 30 degrees away on this side, or 1/6 away from pi. So does it make sense that this is 5 pi 6? This is 1/6 more than pi, so it's 7 pi 6. And this is 1/6 less than 2 pi, or 11 pi 6. So this is where I think even if you choose to do the unit circle, knowing those reference angles helps, because you know all of these are a 1/6 away, so those are all the 6. This one's 60 degrees, or pi thirds. And again, all the other lines that I haven't labeled yet all have the same reference angle, which means they're all 60 degrees, or pi thirds away from the x-axis. So I know that if this is pi thirds, this one is 2 pi thirds, pi is 3 pi thirds, that makes this 4 pi thirds, and this 5 pi thirds, because they're all a third away. So I don't care how you know your angles, but I just try to give you different ways to think about it. That's the angles in the unit circle that we labeled yesterday, maybe? The new part is the points on the unit circle. And again, those points come from if you drew in a triangle with a radius of 1, what the ratios would become, the sine and the cosine. And for pi 6, that would be square root of 3 over 2, 1/2. And remember that 30, 60, 90 triangle, because 30 and 60 degrees, like the opposite side becomes the adjacent side, that when you switch them around, they just switch, right? This becomes 1/2 square root of 3 over 2. Very easy to mix those up, so we got to figure out, make sure we know how to do that. Here's what's really great, just like over there in the pi force. If you know this first quadrant, you know the rest of these, because you just correspond the reference angles, or all the sixths are going to have the same ordered pairs, because they're the same distance away, you just got to get the negatives right. So in quadrant 2, this is the ordered pair, negative square root of 3 over 2, 1/2. 7 pi 6 is the ordered pair, negative square root of 3 over 2, negative 1/2. And 11 pi 6 is square root of 3 over 2, positive 1/2. Nope, screw that up. Negative 1/2. All the thirds have the same ordered pair. 1/2 square root of 3 over 2. Just get your signs right. Negative 1/2 square root of 3 over 2. This one is negative 1/2 negative square root of 3 over 2. And this one is 1/2 negative square root of 3 over 2. And if you put this all together on one circle, that makes the unit circle. In your book, they give you the unit circle. Maybe you noticed yesterday. All together. I like to break it up at first. I also can show you lots of tricks on how to memorize this, so you don't have to feel like you have to memorize every step of this, because you can see there's kind of a pattern going there, because it's a reference angles, because they repeat themselves. So after you get that done, turn the page and don't just start writing. I'm going to give you some. I'm going to give you a trick. Trick number 1. That's kind of cool, right? What's that? This is the unit circle, all right? Notice that there are 3 angles in here. Those 3 special angles, 30 degrees, 45 degrees, 60 degrees, or pi 6, pi 4, pi thirds. So if you want to label those, right, this is 0. The smallest angle is 30 degrees, or pi 6. Pi 4 goes right in the middle, which is 45 degrees, and then pi thirds is at the top. So the unit circle is all the multiples of 30 degrees, 45 degrees, 60 degrees is a multiple of 30, so I'm going to say that. I'm going to go around and label the angles just one more time, just because you've got to be able to do this. You have to know where 5 pi 6 is. Again, if it helps, they repeat themselves. All the ones that are the same distance away, halfway in the middle, are going to be your force. So this is 3 pi force. Here's pi, which is 4 pi force. This is 5 pi force. Here's my 3 pi halves. This is 7 pi force. Some people are really good at just going a step at a time. I find it helpful if I just do all the ones that go together. All the 6 go together. They're all 1 away from the x-axis, right? They're the line closest to the x-axis. So this is 5 pi 6, 7 pi 6, 11 pi 6. Does it make sense where I'm getting this, or you're just copying what I'm doing? And all the other ones are thirds, so 1/3, 2/3, 3/3 is pi. So this is 2 pi thirds, so 1 more than pi would be 4 pi thirds, 5 pi thirds.
Wait, I think you messed up the top part.
No, I didn't.
I thought the third's wrong. Bottom.
No, the thirds are the same. There's a third away from the x-axis, so that's right.
Oh, she does.
They all have the same reference angles. That's where they come from. So let's label the axes, the 0, pi halves, pi, 3 pi halves, and then I'm going to show you a shortcut for quadrant 1. Because if you know quadrant 1, all you got to do is flip them to the right quadrants with the negatives that go with them, and you have the whole unit circle. So really, knowing quadrant 1 is kind of the big thing. This is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. And then I'm going to stop it for you ready, so I can show you a wonderful trick that my good friend Patrick showed me on YouTube.
Oh, he actually not even really kind of.
I just finished. It might be a problem.
Do you have a PhD?
I don't have a PhD. Am I getting a PhD?
You're gonna get it. Well, it sounds like you're pretty close. Why wouldn't you? So
I don't know. I don't even know what you have to do to get a PhD. You have to do like research.
What did you go Dr. X on?
I just want to do all that work. I don't know. We'll see.
You're already doing all that work for like just.
It's 2 classes. It's not 2 classes is not a PhD. You don't know what it takes to get a PhD.
You neither.
I don't know.
And yeah, see.
Maybe someday. If I ever start teaching, here's okay. If I ever start teaching at a college, then I can take classes for a lot cheaper than I'm paying right now. So like right now, I have no plans to get a PhD. But if I start teaching there without a PhD, maybe I could work towards a PhD because I could take a class really cheap. But I don't even know what it takes. I'm probably not going to do it because I don't want to do research. I like to teach math.
What does it stand for again? Doctorate? Like
I don't even know what it stands for.
physics?
Here we go. Make your little comma. Remember, these are fractions, so don't write really big here. But here is the trick of how to do the first quadrant of the unit circle. Start at the top, inside, or outside. I think that's inside. You think that's inside? I think.
Yes.
And count. Go to count. 1, 2, 3. And then count back to the top, and now go backwards. 3, 2, 1. Or you could think 1, 2, 3, and then go over, back up. 1, 2, 3. I don't know. 1, 2, 3. 3, 2, 1. So far, so good, right? Now put everything over 2. One, two, three. 3, 2, 1. Everything over 2. With me so far? Now we're just going to take the square root of all the top numbers. But remember, what's the square root of 1? 1. So we don't have to do the square root. Like, that's just 1. But we're going to say the square root of 3, the square root of 2, the square root of 2, the square root of 3, the square root of 1 is 1. Oh, we just did the first quadrant of the unit circle by just counting to 3 and back. And square rooting and putting over 2 and all that stuff. I don't like the unit circle, so I really use triangles, but you know, whatever. There's also a little hand trick. Remind me, maybe tomorrow I can show you the hand trick. Because you can think of this as your y-axis and this as your x-axis, so then you have pi 6, pi 4, pi thirds, and I can show you a nice little trick.
I like calculus too, which you like better.
Calculus is way better.
No, you like circle or like
Oh, very old. So now you should be able to take this and translate that to everything else, right? All of the 6 are going to have this ordered pair, only with the appropriate signs. So that's going to be negative square root of 3 over 2, 1/2. And 7 pi 6 is going to be negative square root of 3 over 2, negative 1/2. And 11 pi 6 is square root of 3 over 2, negative 1/2. It's the same point. You just have to change the negatives to appropriate negatives. We've done this a lot already today, right? Now, all the pi fourths are going to be square root 2 over 2, square root 2 over 2, but in each quadrant, you have to put the negative that goes with it. So in quadrant 2, the x is always negative. So it's going to be negative square root 2 over 2, square root 2 over 2. In quadrant 3, they're both negative. So it's negative square root 2 over 2, negative square root 2 over 2. And in quadrant 4, only the y is negative, square root 2 over 2, negative square root 2 over 2. One more to go. Pi thirds. All the thirds are going to be 1/2 square root 3 over 2, because they all have the same reference angle. except for in the different quadrants, you're going to put the signs that go with them. So in quadrant 2, which one's negative?
The first one.
X is negative. So it's going to be negative 1/2 square root of 3 over 2. And in quadrant 3, they're both negative. So it's going to be negative 1/2 negative square root of 3 over 2. And in quadrant 4, only the y is negative. 1/2 negative square root of 3 over 2. For me, if I'm using the unit circle, I think what I find annoying about the unit circle is I feel like people feel like they have to draw the entire unit circle every time to do any problem. And for me, I'm much quicker at drawing one triangle to answer a question. But for me, if I'm doing the unit circle for a problem, I just find the angle in quadrant 1, and then I figure out what quadrant I'm actually in, and I'll show you what I mean by that in a minute. Many people, when we have a test, the very first thing they'll do is they'll spend a few minutes and they'll draw an entire unit circle to answer all their questions. And if that's what you choose to do, that's okay. But I'm not ever going to let you have a unit circle to use on the test. Like, you'll have to reproduce it every time. So you want to make sure you don't mix things up, because that could be bad news, right? So how can we use this? Let's do some problems. Is everybody done with this? This is in your book also on page 380. They even put the degree measures for you for this lovely unit circle as well. Okay. Theirs doesn't have the lines in it like I do. They just have the points on it. I don't know. We gotta get through this. It might be tomorrow. Way more. This one more, but.
One more with 3 problems on it. 11 gets specific. Just evaluate three trig functions. I feel like we're building it up.
There will never be a question that I say you must use a unit circle, you must use triangles. Like, it is your choice. On the quiz that we took before, right, I like to give you a quiz before I teach you the unit circle, because I like to force you to learn those 2 triangles at least for a day or 2. But now that we know both options, when I do problems, there will always be 2 ways to do it. You can either use the unit circle points, or you can draw your triangle in, and you will always get the same answer, because really they come from each other, right? They're related. So don't feel like you have to choose one or the other, or sometimes I'm going to say you must use the unit circle. It's your choice. This says using the unit circle, but obviously you can use triangles. Pi-thirds. Is that in our unit circle?
Of course.
Oh my goodness. Here's why people love the unit circle. All you have to know is what is the ordered pair for pi-thirds, which means really important. You got to know where that is on your unit circle without having your unit circle in front of you all the time. But pi-thirds is 60 degrees up here. So think about the cheap way to do it is you start with 1 at the top. So that means the first one's 1/2, which means this is square root of 3 over 2, right? That's from the unit circle. If you know that, you know all the trig functions. Yes.
I don't know yet.
Because it's all, like, if you're using the unit circle, you have to memorize this. Like, you have to know it. Like, you just have to memorize a way to do it. I'm saying I know the shortcut way is you start with 1, 2, 3, so that's how I knew 1/2 was first, and I know square root of 3 over 2 is the one that goes with it. Like, you just have to memorize it. And then I can say the sine of pi-thirds, or you can say the sine of t, doesn't matter here. In the unit circle, sine is just the y-coordinate, which means what is the sine of pi-thirds? Square root of 3 over 2. I didn't need a triangle. I didn't need SOHCAHTOA. I didn't even really need math. Everybody had another unit circle. Cosine of pi-thirds. In the unit circle, cosine is always just the x-coordinate. And what is the x-coordinate at pi-thirds? Which means sine and cosine are now super easy to find because they're just the y and the x-coordinate. Tangent, this is where people are like, oh my gosh, this looks terrible, right? How do we find tangent? Y over x, and these are all fractions, and so people freak out, but it's actually really easy. If you did, I'm going to write it out on this first one, but if you did square root of 3 over 2 over 1/2, how do you divide fractions? You multiply by the reciprocal, but what's super cool, all of these have the same denominators, yes? So when you flip it up, those denominators are always going to cancel out. So when you are doing y over x, the 2's are always going to cancel when you flip it up. So the shortcut is you can just take the top of the y over the top of x, and you don't even have to freak out about fractions. It's just square root of 3. That's not really a trick, it's just the math of how it works, but it's super cool. And I put 3 trig functions, but we really could find the other ones too. We could flip these all over and work it out as well, right? Like sine would just be 1 over y, so you flip that over. Secant, sorry, that would be cosecant. Secant would be 2 over 1. Tangent would be 1 over the square root of 3, right? So we're just doing sine, cosine, tangent, because they're our favorite. Now this makes finding the ones on the axis much better also. What is the ordered pair at pi? That is my x, that is my y. I can find all the trig functions by just knowing x and y and those ratios. So what is the sine of pi? 0. Sine of pi is y, is 0. What is the cosine of pi? I can't write. Cosine is x, cosine is -1. What is the tangent of pi? 0. Tangent is y over x, 0 over -1. What would the cosecant of pi be? Undefined because it'd be 1 over 0. What would the secant of pi be? What would the cotangent of pi be? Undefined. You're going to have undefined values. So you see why people like the unit circle? Seems like it takes out some work. What about this one? Negative pi 6. Oh no, that's not on my unit circle. I must not be able to do it. What shall I do?
Go backwards.
Do it.
That's probably what you'll do. There's options.
Wow. That was very hurtful. Check the back even.
One option is, where is negative pi 6? Go backwards like this, right? Is there a point on my unit circle that corresponds to negative pi 6, only I labeled it a different angle? 11 pi 6, which means if you can find the one that goes with it, you can still use that ordered pair that goes there. You also could do, I think Chloe said, you could find the positive angle. Like you could do add 2 pi. What is that as a positive angle? It is 11 pi 6. So either way, you're going to end up at that same spot, whether you think of going backwards and finding that point or going around. So that's where I'm going to show both ways on this one. If you're a unit circle person, you got to know that ordered pair. So for me, I always think of the top one is square root of 3 over 2 1/2. So down here would be square root of 3 over 2 negative 1/2. How do I know that? Because I memorized my unit circle. And if you're going to be a unit circle person, you got to memorize it. If you think this is terrible and you say, I like my triangles better, this is where you would say, oh, this would be a lovely reference triangle with a 30-degree reference angle. And you got to know those ratios, that this would be 2, this would be the square root of 3, and this would be -1. And then you can do the ratios of the triangle like we did before. Or if you're a unit circle person, you can just use your ordered pair and say the sine of negative pi 6 is negative 1/2. The cosine of negative pi 6 is square root of 3 over 2, because it's just y and x, same answers we get up here. And the tangent of negative pi 6 would be what?
Negative 1 square root of 3 over 2.
Not over 2, just negative.
Oh, you don't, you can't.
Right, the 2's cancel out?
No,
I thought you said 2. Did you not say 2? Sorry. Would be this, right? I think that's what you're going for. Sorry. I thought you said negative 1 over square root of 3 over 2. You see how there's 2 options? You get the same answer? I usually do triangles, but when I teach the unit circle is fresh in my head, and I like the unit circle for a while. So I always revert back to triangles. This is different than what's on your homework because I can't cover all of what I want you to do today. So tomorrow we'll actually add on day 4 of this, or day 3 continued. So eventually you'll do all of day 3 homework on your homework sheet, but today you're only doing 29 and 31. If you didn't complete the other problems yesterday that said do without a calculator, you can go back and do those with the unit circle. But these are the ones that kind of, you should either be doing the unit circle or the triangles. And then 67 through 70.
So, do we do 39 and 42 yet?
No.
So what are we talking about yesterday?
You do this tonight, which is different than on your own worksheet.
What did we talk about yesterday?
How to do this with reference angles, which you missed, so I'm guessing you're going to be a unit circle guy. Bet you go back and watch the video.
Why, did we learn that on Monday though too? The reference triangle?
I don't know. You should watch it.
Yeah, I was gonna like do last night, but that was Rose game, I didn't get home till late.
Tomorrow we'll finish this up. Friday we'll do a worksheet. We'll eventually get to the unit circle song, but it's not happening today, I don't think.